All right, so now we're going to talk about strategies for simplifying operations with exponents. So we're going to be trying to bring all of the things that we've learned about exponents together. So we're going to do this through examples. So the first thing you need to remember is that for all of your choices, you really want to keep your bases together. And one thing that sometimes kids forget is that, or students forget, is that my bases include the numbers. So here, when I have 3 and 4, it's really 3 times 4. So 3 times 4 is 12. So I've brought that basically base 10 together. Now I'm going to look at my base of r. So I have an r squared and an r to the 4th. And I remember because I'm multiplying them, and they're the same base, I'm going to add their exponents. So 2 plus 4 is 6. And then finally, I'm going to worry about my s base. And I have to remember that this s over here has an implied 1 as its exponent. So I'm going to keep the base of s, and I'm going to add 1 plus 3 is 4. Now, looking at my second problem, I see that I once again have some numbers, and I remember that fraction bar is really division. So I'm going to look at the numbers first. That's 2/8. 8 doesn't really divide into 2, but I do see that I can simplify the fraction of 2/8. So I'm going to go ahead and make that 1/4. And then I'm going to look at my y's, and I'm going to see my bases are the same there. And this is really y to the first. Make that a little bit bigger. And then I have y. Remember, with division, it's 5 minus 1 is going to be the exponent of the numerator minus the exponent of the denominator. And 5 minus 1 gives me 4. I could write it like this, 1/4 y to the 4th, or I could have y to the 4th divided by 4. Either of those two answers are fine. And so looking at our third example here, let me push this up just a little bit so you have a little more space to see it. I have 1/3 cubed times 1/3 squared times 1/3 squared. Here the base is the actual fraction of 1/3. The reason being these exponents are all on the outside of the parentheses. So I'm going to go ahead and resolve those to the outside. So I'm going to keep my 1/3 inside the parentheses. That's my base. Then I'm going to add 3 plus 2 is 5 plus 2 is 7. And then I'm going to go ahead and I'm going to apply my exponent rule here. So I'm going to have 1 to the 7th. And I'm going to have 3 to the 7th. That's the power of a quotient where I apply that exponent to everything inside. And then that's ultimately going to be 1 to the 7th power is 1, and 3 to the 7th power is a number I could put in my calculator, but I'm going to opt to leave this as simplified for today. And then I'm going to look at the next example, and what I see is a little bit different than what we saw on our original. I see that I have a mismatch. So up here, I had things that matched up. I had some r's that matched up, the s's matched up, I had some numbers, but down here I'm noticing that not all my variables match perfectly fine. I'm going to start with my numbers, and I have 2 times 8. Well, 2 times 8 is 16. Then I'm going to bring my like bases together. X cubed times x to the 4th. I'm going to use that product rule, so I want to go ahead and keep the base of x, and then add 3 and 4 together to get 7. And because y squared doesn't have anybody left for him, we're just going to leave him alone. He's as simplified as we're able to get. And now our final problem has a similar thing where I don't have a match with some of the bases. I look at 9/5, and 9/5 is already simplified. Then I'm going to take my r's, and I'm going to remember that I subtract the numerator exponent minus the denominator, so I get 4 minus 2 is 2. And then I'm just going to have t to the 6. I could write it like that. I could write 9/5 r squared t to the 6th, that works as well. Either of those answers typically is fine depending on what you're looking for. And so that's just simplifying using all of the exponent rules. Here you'll notice that all of the exponents were positive. Please see part 2 for some more complicated simplifications as well. Thank you.